Welcome to video 2.4 on average atomic mass. In this video, we're going to look at atomic mass, and we're going to understand on our periodic table how the atomic mass or the atomic weight was determined for the number used on our periodic table. We'll also give you the calculations, and I will show you how to calculate the average atomic mass if you're given the percent abundance of an isotope for an element. So it's a pretty simple idea. All we're doing is taking the average. So here we go, two key vocab terms, atomic mass units and the average atomic mass. So we consider an atom. An atom, you know, is made up of protons and neutrons and electrons. Well, we ignore the electrons because they are so small in mass compared to the protons and neutrons. They are something like 2,000 times smaller than that of a proton or a neutron. So we do not consider their mass when we talk about the mass of an atom because it's so small, it's insignificant. But when we go and talk about the mass of an atom, we're really looking at the mass of the protons and neutrons, as you saw in the last video when we talked about the isotopes. What we're going to do now, though, is we're going to come up with our own new man-made unit. This is called an AMU, atomic mass unit. Sometimes this is abbreviated as AMU, and sometimes it is abbreviated as just U. One AMU is defined as the mass of one proton or one neutron. Again, we're talking about something that is so small that everyday equipment cannot measure it. And that some of this stuff is actually more theory work. And so when we talk about this in theory, we created this unit called an AMU, and we say that one AMU is the mass of just one proton or one neutron. And so then we determined what AMU was based off the carbon-12 isotope. So we have an atom of carbon. That atom of carbon we know has 6 protons and 6 neutrons, and so it's the most abundant isotope of carbon, and we say that that has 12 AMU. So we determined that 1 AMU was equal to 12, or 1 AMU is equal to 1 proton or 1 neutron, and that carbon-12 is called carbon-12 because it has a mass of 12 AMU because we know it has 6 protons and 6 neutrons. So again, not a super complicated idea, it's just something you got to accept. AMU is the unit and is defined as the mass of 1 proton or 1 neutron. So when we talk about the average atomic mass, we're talking about the average mass of all the carbon that's out there in the world, or all the lithium that's out there in the world. You learned from the last video that carbon can exist as just regular carbon with 6 protons and 6 neutrons, or it could be in a different form known as an isotope, as carbon-13 or carbon-14. If you remember from last video, carbon-13 was because there were 6 protons and 7 neutrons. Carbon-14 exists because there are 6 protons and 8 neutrons. Again, where did this number 13 came from? It just came from us adding up the 6 and the 7. Where did the 14 come from? Because it came from the number 6 and the 8. So now the question is, when I look at my periodic table, I can look at carbon and I see right here it says that carbon has the average atomic mass of 12.011. What that means is that number in the periodic table says that all of the world, scientists around the world have been massing and taking the mass of the carbon atom throughout time and for the last 100 years. And during the last 100 years from all over the world, they've been finding out the masses of these individual carbon atoms and then finding their average. What you can see here is because it's 12.011 is that carbon-12 is the most common form of the carbon atom. But yet it's not the only form. Here you can see carbon-13 and carbon-14. So this number represents the average of all 3 of these atoms with respect to the abundance that they exist. Since this one is very abundant, it has a higher percentage of existence, it has more of a weighted average, or the number will be more weighted towards this mass, and that's why we get 12.011. But why is there a 0.011? Because there are some carbon-13s out there, and there are some carbon-14s out there. So again, this number on your periodic table is just the average mass of all the carbon atoms out there in the world that we've experimented on so far. And those averages come out to a 12.01. It's weighted towards this mass because this carbon-12 exists in a higher abundance than these guys, which means there's more of this than there are these. These are very rare isotopes, and this is the main isotope. So when we talk about finding the average atomic mass, all we're doing is just looking at the average of all of those isotopes. So again, every element out there in the world typically is a mixture of isotopes. If you get a scoop of gold or a scoop of copper or a scoop of carbon, in that scoop in your hand is going to have a mixture of the isotopes. Might be more one isotope than the other, but it's still going to be a mixture. And so what scientists have done is they have calculated the average atomic mass using the abundance, using how often a certain isotope appears in nature, and calculated that compared to their mass. This is called the weighted average. And so what we do is we have used this concept of the weighted average to come up with the numbers that's seen on the periodic table. For example, here's lithium. Lithium can exist at lithium-6 or lithium-7. And you can see from its average mass that the lithium-7 isotope would be more common than the lithium-6. But this number right here came from the calculation I'm about to show you of how we just take how often it occurs compared to its mass. So it's actually a really simple equation. You just kind of got to see it and practice it a few times, and then you should be good to go with it. So here's a problem that you will see. Determine the average atomic mass for a sample of copper if 69.15% of the sample of the copper is copper-63 and 30.85% of the copper is copper-65. So as we get started in this problem, there's a few things you need to remember from the last video. First of all, why is this called copper-63? Well, it's called copper-63 because it has an atomic mass of 63, meaning the total amount of protons and neutrons in this isotope is 63. So since it's copper-63, we can write 63U or 63 AMU. And then copper-65, same as 65U, meaning that its atomic mass is 65. So now how do I find the average here? How do I find this weighted average? Well, all we do is we take the percent and we turn it into decimal form. And then we multiply that percent by the atomic mass of that isotope. Then we add that number to, again, the percent turned into a decimal multiplied by that atomic mass. So when you do this calculation, you take 0.6915 times it by 63U, and then you add that to 0.3085 times 65U, comes together as 63.55U. This is the same idea on how your grade is calculated here. Your grade in here is 60% exams. You add 60% times your exam grade. That gets added to your mastery quizzes, which is 10%, which gets added to your homework, which is 15%, which is then added to your lab grade, which is also 15%, to give you your final score, meaning that your exam grade is weighted more heavily than your homework, your lab, and your mastery quizzes. So again, what you know, because again, the exam and mastery quizzes, you proving what you know, is majority of this class. So it's the same idea. It's a pretty simple idea once you get used to it. The only trick here is being able to convert percent into a decimal and then setting up the right masses in the right spots. So here we go. Now it's your turn to try. Pause the video, try this yourself by following this format, and see if you can come up with the right answer. And for this class, let's always just go to 2 decimal places when we're talking about atomic mass. So again, whenever you get an answer that's deal with atomic mass, just go to 2 decimal places to keep it simple for us. Pause the video, try it, and then when you're ready, watch me show you how to do it. All right, so now that you have come back from the video, here's my hand showing you how I would answer this. So again, I read the question, and I see it's asking average atomic mass of rubidium. So I'm going to go ahead and set my problem. I'm going to say I know that rubidium-85 has a mass of 85. And I need to multiply that by the percent in decimal form. Once this is multiplied together, that will be added to rubidium-87, which has a mass of 87, comes from right there. And that will be multiplied to 27.8% in decimal form. So all I simply do now is put that in my calculator. I would take 85 times 0.722, and I get the number 61.37. Then I'm going to add that to my 87, times 0.278, and I get 24.186 and I just simply add those two numbers together, 61.37, and I get 85.56 because, like I just said, go to two decimal places. And this will be labeled U, or you can even label it MNU. If I was given a third, like rubidium 89 at like 10% or something, you would just simply add another parentheses here, and it would just get added again as you take the mass times that percent. So whether you have 2, 3, 4, 5, or 6, all these equations are the same. Hopefully that looks pretty simple to you. You will be practicing this in class. So again, what did you see in this video? You just saw that atoms are measured in AMU, which stands for atomic mass units, where one AMU is equivalent to one proton or one neutron by mass. Then we also found that the masses given on the periodic table are actually weighted averages. They're the weighted average of all the known isotopes of that element and their relative abundance, which now you know how to easily calculate because I showed you how to do it. I hope this is a good video for you. Do the lesson. We'll have some time to work on it in class. We'll get this knocked out right away. Thank you.